focus of Newton's first law of motion is an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This is sometimes referred to as the law of inertia.
This is an example of Newton's first law. The soccer ball begins at rest and would stay at rest until acted upon by an unbalanced force. In this case, Kyle's foot is the unbalanced force. You could also see that the ball would continue to keep going until an outside force stopped it. In the first clip, an outside force stops the ball, which is gravity. In the second clip, the outside force is John's foot.
This is another example of Newton's first law. Granny begins at rest. When Jill pushes him, she acts as the outside force, this resulting in Granny losing balance, falling to the ground.
Newton's second law provides the definition and calculation of force through mass and acceleration. The law says that acceleration is dependent on the force acting upon an object and the mass of the object.
This is an example of Newton's second law. When Jill attempts to lift the bar, she cannot because there is not enough force exerted. When John lifts the bar, he is successful. This is because he exerts just enough force, therefore enabling him to do multiple bicep curls.
In this example, there are two balls with completely different masses. The blue ball is a small bouncy ball, whereas the black ball is a heavy medicine ball. When Kyle and Granny push the balls, they both result differently. Kyle pushes the bouncy ball that takes off and accelerates. When Granny pushes the medicine ball, it only moves a tiny bit. This is because since the balls have different masses, they need different forces in order for the balls to accelerate at the same speed.
This example shows the difference between John driving his car uphill versus on a flat road. When John drives uphill at 15 miles per hour, his car struggles. This is because his car requires a bigger force to go uphill, but when he drives down a flat road at 15 miles per hour, he has no issues.
Newton's third law states that for every action there is an equal and opposite reaction. The statement means that in every interaction there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object.
In this clip, Kyle lays on the floor. The action would be gravity pushing down on him. Then the reaction would be the normal force pushing back up on him.
This is an example of Newton's third law. When John pulls up and slams on the brakes of his car, him and Kyle both jerk forward. This comes back to the law because for every action there is an equal and opposite reaction. The first action would be John hitting the brakes. The equal and opposite reaction would be Kyle and John jerking forward, then backwards.